Assalamu alaikum class. As we know, this is our 8th online lecture of differential equations, which is undetermined coefficients approach or superposition approach. What we did in the last lecture, or lecture number 7, in the last lecture we solved differential equation for general solution, and another question was solved for particular solution. And we solved many times for particular solution, for complementary solution, or for the general solution. We solved many questions, but in the from the last lecture we are using undetermined coefficient approach or superposition approach. We did 2 questions, and in this lecture we are solving this example, which is forming yp by superposition. Again, we are using the same technique, but what is the difference from the last lecture here? Here we have the right hand side consists of 2 type of functions, which is our function g of x. This is linear polynomial 4x minus 5, and this is another function x e raised to power 2x. This is another function. So our g of x is actually made up of 2 functions. This is linear polynomial and this is exponential function. While in the last lecture we solved the questions were very simple. One was quadratic polynomial and the other was sine function, but here we are having linear polynomial as well as exponential. So the given differential equation is y double dash minus 2y dash minus 3y is equal to 4x minus 5 plus 6x e raised to power 2x. This is the differential equation which we have been asked to solve. Solve means we need to find the complete solution, or the general solution means we need to find yc as well as particular solution yp. So now move towards the solution. The step number 1, we know, as we have to find the complete solution. So what we will do, we will first find yc and then yp, and then we will find the complete solution yc plus yp. So we know how to find yc. What we always do, we take the right hand side of the left hand side of the given differential equation, convert it in, make it homogeneous, the solution of the associated homogeneous equation. This is, and then what we do, we make auxiliary equation from the following equation: y double dash minus 2y dash minus 3y is equal to 0. Here in this step they didn't mention the auxiliary equation, but we know we always make auxiliary equation as m square minus 2m minus 3 is equal to 0, which is quadratic equation. So when you will solve the following quadratic equation or auxiliary equation, it will gives the root minus 1 and 3. So minus 1 and 3 both are real in distinct root. So the complementary solution will be c1 e raised to power minus 1 into x, means c1 e raised to power minus x, plus c2 e raised to power m2x, and m2 means second root was 3. So the complementary solution for the following homogeneous equation whose auxiliary equation has been made is c1 e raised to power minus x plus c2 e raised to power 3x. Now move towards the second step. From this step actually we are solving the remaining part for yp, and yp or particular solution actually depends on the right hand side of the equation or the function g of x, and we know this is the next. The presence of this in g of x suggests that the particular solution includes a linear polynomial. As in the last 2 questions we solved, we assume a particular solution with undetermined coefficients, which are like the given g of x. So here this is linear polynomial as mentioned here, and this is the product x e raised to power 2x. This is exponential function, and we know if we will differentiate this one, it will give x e raised to power 2x, 2x e raised to power 2x, and e raised to power 2x. These three terms will be there when we'll differentiate the following g of x. So we assume that the particular solution includes both x e raised to power 2x and e raised to power 2x. In other words, g is the sum of two basic kind of function. What we were in the last questions, we take only one function g of x. In the first question we took it as a quadratic polynomial, and then in the second question we took it as a sin x and cos x function. But here we have two function, linear polynomial as well as exponential function. So our g of x is made up of two function, g1 of x and g2 of x, which is first one is polynomial and the second one is exponential. Now as our g is made up of two functions, so our yp will also depend on these two functions. For g1 of x or polynomial, we will calculate yp1, and for g2, which is exponential function, we will have yp2. So to find yp, we will calculate yp1 as well as yp2, and then we will add to give yp. Now for this part, 4x minus 5, we took yp1 is equal to ax plus b. This is actually, we are assuming these are undetermined coefficient. So as we are using the undetermined coefficient or superposition approach, so yp1 is ax plus b and yp2 is for g2, and g2 is exponential function. So yp2 is equal to cx e raised to power 2x plus e raised to power 2x. Here we took these two undetermined coefficient, capital A and capital B, and here so we will have to move further for these coefficients c and e. We didn't took d. Why? Because d is also here the derivative, so that we may not mix, that's why they took e here. So this is yp2, second particular solution which we assumed. Okay, now yp is equal to yp1 plus yp2. Substitute this yp1 here and this yp2 here, gives yp is equal to ax plus b plus c x e raised to power 2x plus capital E into small e raised to power 2x exponential. Now this is yp. What we do after this, we actually do v, as this is the particular solution of this differential equation. So this solution must satisfy this differential equation. Now substitute these yp, yp dash and yp double dash in this equation, which gives yp double dash minus 2yp dash minus 3yp is equals to 4x minus 5 plus 6x e raised to power 2x, and yp has been given. We will find yp double dash from this equation, yp dash from this equation, and yp has already assumed. So put these three terms yp, yp dash and yp double dash in the following expression. So after putting these expressions in the left hand side of this equation, given equation, we will after putting or after substituting, we will comparing the coefficients of like powers or like terms. As if the coefficient of x term is 4 here, what is the coefficient of x term here? Minus 3a. If the coefficient is the constant term is minus 5, What is here? Minus 2a minus 3b is equal to minus 5. X e raised to power 2x coefficient is 6. So x e raised to power 2x coefficient is minus 3c. And this is also another equation, 2c minus 3e, which is e raised to power 2x. Here we don't have this term, so this is equal to 0. Now we have these 1, 2, 3 and 4 equations. What we will do? We will find a from here, put that a here, we will have b. From this we can calculate c, so putting c here we will have e. After calculating a, b, c and e for undetermined coefficient, we will have the values of these coefficients. What we get the values of these equations? A is minus 4 by 3, b is 23 by 9, c is minus 2 and e is minus 4 by 3. We calculated a, b, c and e. Now what we will do? Put all these terms in this equation, because we have to find yp. So yp is equal to a value, b value, c value and e value. Put these values. Yp is equal to, as a is minus 4 by 3, minus 4 by 3x plus b is 23 by 9, okay, plus c, x e raised to power 2x, c is minus 2 x e raised to power 2x and e raised to power 2x, capital E is minus 4 by 3, minus 4 by 3 into e raised to power 2x. Now we have find the particular solution. What is the last step? Last step is finding the general solution, and we know general solution y is the sum of complementary solution plus particular solution. So y is equal to yc plus yp, and we already have calculated yc, which is c1 e raised to power minus x plus c2 e raised to power 3x. This is yc plus this value is yp. So this is the general solution or the complete solution. Okay, this was the last step. Now you people can further solve or read this from the book. Now move towards the other example, which is a glitch in the method. And this is another example. We have to find the particular solution of this equation, means we only need to find yp, we don't need to find yc here, because it is mentioned in the question that you need to find the particular solution. And the given differential equation is y double dash minus 5y dash plus 4y is equal to 8 e raised to power x. What actually we are doing in this superposition approach? We only take g of x as the right hand side as a function g of x, and we examine what kind of this function is. Then we assume our particular solution like g of x with undetermined coefficients. So and we always take derivative of that equation, particular solution, and put in this following equation to satisfy. So what can be the function for what can be the particular solution for this equation? Let's see. Differentiation of ex produces no new function. We all know the derivative of ex is always e raised to power x. There is no any other function. Therefore, proceeding as we did in the earlier examples, we can reasonably assume a particular solution of the form yp is equal to a e raised to power x. Whenever we assume the particular solution, we just check or examine what kind of given g of x is, what kind of that function is, and we always take a similar function as a particular solution. We assume. So if we assume yp a e raised to power x, but when you will solve the question by this substitution will result yields the contradictory statement 0 is equal to 8 e raised to power x. So we have clearly made the wrong guess for yp. You may not understand because I am just telling from the book. If you people will solve by taking yp a e, which is a e raised to power x, when you will differentiate and put in the equation or the question given, it will give 0 is equal to 8 e raised to power x, while 8 e raised to power 8 ex can never be 0. So we have made the wrong assumption. We will not take yp as a e raised to power x. So what we will do why actually, when we will have the complementary function or complementary solution for the given equation, if we will calculate that will be c1 e raised to power x plus c2 e raised to power 4x. These two terms already have been calculated in the complementary solution. So whatever the term has been calculated in the complementary function, we will never take or assume that in our particular solution. So we will take the particular solution or assume as a x e raised to power x. Now what we do, differentiate it, yp dash is equal to ax e raised to power x plus a e raised to power x. Again differentiation of this equation gives yp double dash ax e raised to power x plus 2a into e raised to power x. Now put this yp dash and yp double dash in the main equation or in the question, which was y double dash minus 5y dash plus 4y is equal to 8 e raised to power x. So yp double dash is ax e raised to power x plus 2ax, and minus 5 into yp dash is this term plus 4 into yp is this term, which is equal to 8ex. So after solving, it gives minus 3a e raised to power x is equal to 8 e raised to power x, which implies a is equal to minus 8 by 3. So put this 8 here in the particular solution, and so we will have yp is equal to minus 8 by 3 into x e raised to power x, this x into e raised to power x. So this is the particular solution. From this equation, what we learn that if we assume any particular function, that may be our wrong assumption. As here in this question, when we were taking a e raised to power x, it was a wrong assumption. So we change it into ax e raised to power x. Now let's move towards another question. Okay, before solving the other question, I'll let you people know that this is a table of trial particular solutions. Means as whenever we have to find the particular solution or the general solution, we need to find yp. And in undetermined coefficient or superposition approach, we first examine what kind of g of x is given in the differential equation or in the question which we have been asked to solve, and what we assume the form of yp. What will kind of a particular solution can be. This is the table. Let's say if you have been given any constant, we will take a or any constant. If we have any linear equation 5x plus 7 or 5x plus 10 or x plus 2, any linear equation, we assume the particular solution as ax plus b. If that is quadratic equation 3x square minus 2 or anything, that will be ax square plus bx plus c. If that is cubic or third order equation, this will be like this. If it is sine 4x, a cos 4x plus b sine 4x. In sine and cos we will take both functions, because as in the first question we solved, by when we differentiate yp, we have both cos and sine term present there. If we have e raised to power 5x, then a e raised to power 5x. But if we check this in our question which we did right before, this was our wrong assumption, because in the differential equation given it was not satisfying. So this is the table. Just you people must remember that if what kind of g of x is given, then how we will assume our yp according to that g of x. Now let's move towards another question. In this example we are discussing different forms of particular solution. केस 1 हमारे पास क्या है, जैसे कि हमें 2 क्वेश्चंस गिवन है, हमें उनकी डिफरेंट फॉर्म्स फाइंड करनी है. We are not finding the general solution, we are not finding the complementary function, or not finding the particular solution. We are just finding the form. What we are assuming in yp, just determining the form of particular solution, that what kind of g of x is given, what kind of yp you will have to assume. So the question number 1 is y double dash minus 8y dash plus 25y is equal to 5x cube e raised to power minus x into minus 7 e raised to power minus x. So for this part we can write g of x as minus 5x cube minus 7 into e raised to power minus x. From the let's move towards table. It said using entry 9 in the table as a model, we assume a particular solution of the form this. What is the ninth entry? X square e raised to power 5x means when we have product of x term and exponential term. Here we have x term and product with exponential term, so we will assume this we will assume this yp particular solution, ax square plus bx plus c into e raised to power 5x for this term. But here as this is cubic, so we will assume yp as ax cube plus bx square plus cx plus e into e raised to power minus x, so this is e raised to power minus x. Now the other part is y double dash plus 4y is equal to x cos x. What will be the value here, or what will assume yp here? As in b part g of x is x cos x. Now move towards 11th entry of the table, which is x cos x or x sin. The 11th entry is x square sine 4x. Okay, what we will do here in 11th entry, this is 5x square sine 4x. This can be sine x and cos x, any of both sine x and cos x. If this is 5x square, it's not necessary this is x square, this can be x, this can be x cube, and this can be any x power. So what is that? If this is quadratic, we will have quadratic into cos plus again quadratic into sine, means we will take, if this is sine we will take both sine and cos term, if this is cos again we will take both sine and cos terms, and whatever the x is here, if this is quadratic we will take quadratic with them, if this is linear we will take linear with them. And what is in our question given, it is x cos x. X is linear, so we will do ax plus b into cos x. Again we have to take sin x as well, so cx plus e again linear into sin x. So this is our assumed yp. We can for which we take help from the table, so you people can also take help from the table, or can take idea from the table how we will choose yp for the questions. Now let's move towards the other example, which is forming yp by substitution, sorry, by superposition. Again we are forming yp as we did in the last two questions. The given question is determine the form of a particular solution of this kind of differential equation, which is y double dash minus 9y dash plus 14y is equal to 3x square minus 5 sine 2x plus 7x e raised to power 6x. What we have to do for the particular solution, the first step is we have to check what kind of g of x or what kind of right hand side function is. If it's sine, if it's x term, if it exponential, or if it is combination of these all. If we see this is x square means quadratic equation term, this is sine function, this is exponential function. We have three kind of function here. So what we will assume yp here, we will assume yp for this term separate, for this term separate, and for this term separate, and then we will add all these yp's. So yp1 is for this quadratic equation, this, as this is second order term quadratic equation, so this is ax square plus bx plus c. Now corresponding to the second term, 5 sine 2x. Now for the third term is exponential, so corresponding to 7x e raised to power x, we assume yp is gx plus h into e raised to power cx, as x is the linear term, so we assume this linear term into e raised to power 6 is whatever the e raised to power is given, we will take here. So this is yp1 for this term, yp2 for this term, and yp3 for this term. We assume these separate, but actually these the combination of these three will give the resultant particular solution, which is yp is equal to yp1 plus yp2 plus yp3, that is equal to sum of these three. Now what we will do, we will compare, we will first differentiate yp dash, then yp double dash, and put there by comparing this right hand side with the following equation, or which we put in the equation. We will find the unknown or undetermined coefficients. So this is how we find the particular solution for different kind of g of x, or for different kind of right hand side function. Now you will solve all other example in the 4.4 exercise. You people will solve that. Thank you.